this is the final video for the supplemental review. So I'm going to go back to a couple of questions over here on the review guide. I just need to find it. Got a lot of papers around me. Okay, so first off, let's see. I already did these. These should be very easy problems for you. You're going to come back and do this page. And all of this will be calculator problems. Okay, so this entire page, put stars next to all of them. And you're also going to finish off all of these. So I didn't put stars next to these, but let me go ahead and do so. It's the rest of the page, guys. I mean, it's just front and back, everything here. Okay, so all of this. Okay, so this is all calculator problems. So this will not be given to you, this formula, by the way, but this one right here is just asking for turn this angle 480 into radians. So here, guys, 480 degrees. So remember, this is 2 pi and this is 360. Okay, so I'm sorry, this should be the other way around. 360 should be down here because I'm trying to get rid of the degrees. They're trying to cancel each other, and the 2 pi should be up here. So I'm just going to go ahead and plug this into the calculator. And so the degrees cancel, so 480 times 2 pi divided by 360. And when I do that, let me grab my calculator. I don't have it in front of me. So, okay, you're going to get 480 times 2 is 960 pi over 360. And from here, guys, you're just going to reduce. So, okay, well, my calculator's not doing that, but I can continue to reduce this. So, this would be 16 over 6 pi, which I can continue to reduce. So, divided by 2. So this would be 8 pi over 3. So, I mean, this is just, you're going to have the calculator, so don't even worry about it. So, 8 pi over 3, and that's all it is. So here, the only thing is, had I been starting with radians, then the 2 pi would have been on the bottom, and the 360 would be on the top. So that's the only difference. Next problem is, a wheel has a radius of 15 millimeters and an angular velocity of 10 radians per second. What is the linear velocity on the wheel? Okay, so this equation is just the radius multiplied by this is what we call angular velocity. So this is the radius versus the angular velocity. So one important thing, this has to be in radians per second, though, or radians per some unit in time. Okay, so it doesn't have to be per second, but has to be in radians, which luckily it's already in radians. So here, just multiply 15 times 10. So 15 times 10 is 150. And this is, well, I should have put the units, millimeters, and this is already in radians per second. So this is just millimeters per second, which is answer C. Okay, very simple. Okay, so that equation not given to you, so it's just multiply the two numbers. Yes, 15 times 2 to 10. So this one I'm going to take a little bit of time with. So again, you need to know sine, cosine, and tangent. These are the important ones. Okay, so If I read this problem, oops, that's not very clear. Okay, so at a certain time of day, an 84-foot tall tree casts a shadow on the ground that's 47 feet long. Okay, so determine the angle elevation theta from the ground to the top of the tree. So here, guys, I have the tree here, which they told me is 84 feet. And the shadow that it's casting is 47. So this is the angle from the ground to the top of the tree. Okay, so if I label this is the opposite, this is the adjacent, and over here is the hypotenuse. Now, what I need you to realize is I'm asking for the angle, so I'm not solving for h. I don't need it. But I have O and I have A, so I can use tangent to solve for my angle. So I'm going to do that. Tangent theta equals over A. And so I'm going to put tangent theta equals O, which is 84, and A is 47. And you just use NSolve for this one. That's all you need. You can have a calculator, so don't worry about it. And when you do that, you end up with the angle being 60.8 degrees. Okay, so it's just important to know which one to use. Okay, now the last one here is the law of sines, and I went ahead and put a couple of problems here, and oops, this is not the right one. Also on your formula sheet, law of sines and law of cosines. And so this one, guys, what I need you to remember, law of cosines, because I will ask you one, is when you have side angle side. Okay, when the information they give you side angle side. So here, I mean, this one's a lot simpler. You just plug in the numbers, and just so you can look over here on the questions I gave you to solve, I went ahead and just put, this is what you're working on, law of cosines, and you can see that I have side angle side. So work on those problems. I don't have any examples on these on this set of notes, but I don't think you really need any review on that. Just to look at it, and you'll start to remember. So this is a law of sines problem, because if I look at the information they gave me, I don't have side angle side. They gave me, they gave me angle side angle. Okay, and so I'm using the law of sines, which you do not have to memorize. That's on the reference sheet. And they're asking for the distance from the lighthouse to the ship. So here's the ship, here's the lighthouse, this is the distance I'm looking for. So first thing I want to do is label. So over here, this is going to be little b. On the other side, little a, and this is, since this is, we'll call this angle C, this is little c. Okay, so when I'm looking at the law of sines, I only need two of these. So here I'm looking at, well, side B I need, right? That's what I'm looking for. So I need this one. And I need one where I know the angle and the side. Well, I know this side, but I don't know this angle. Okay, and I know this angle, but I don't know this side. So the easy thing for me to do is, well, I know the other two angles, so I can find this missing one. So angle C is just 180 minus 57 minus 64. Okay, which is 59 degrees. So this angle over here is 59 degrees. So now I know the angle and I know the side. So I can use information for angle C, and I don't need any of this from angle A. Excuse me, for side or angle A. So I start to plug in my numbers. So sine B, so my angle for B is 64, over my B, which I don't know, okay, equals sine for angle C, which I just found out was 59 degrees, and the side is 40. So I would use NSolve for this problem again. So this is it right here, and I solve for little b. And when I do that, I'll go ahead and solve that right here. I get that little b is equal to 41.9 miles. Okay. So, not very difficult, guys, just something we need to go over. And it's a calculator problem, so this is a pretty simple one to go through. Again, guys, please study, and I will see you all on Monday.